Hi, Geometry. This is Mr. Manor. I'm going to teach you section 7.2, parallelograms. Our essential question of the day is, what are the properties of parallelograms? If you would like, you can make that little symbol instead of drawing out a whole big parallelogram. Makes it a little bit easier and a little bit quicker. So as you're taking notes, feel free to pause this video as you needed or as needed to catch up. I'm going to go right into the properties of parallelograms. There are 5 of them that you need to know. First of all, opposite sides are parallel. From the word parallelogram, opposite sides will be parallel. Got another opposite for you. Opposite sides are congruent. Remember, congruent means the exact same size and shape. So in this case, just size. They'd be the same length. Opposite sides would be the same length. Opposite angles, and that's my angle sign. Opposite angles are also congruent. They're going to be the exact same measure. Opposite angles will be congruent. There are 2 more. Diagonals bisect each other. Diagonals are when you draw across from opposite vertex to opposite vertex in a parallelogram. So I'll show you that in a minute when we get to the problem. Bisect means to cut into 2 equal parts. Bisect, cut in half. The last fact is that consecutive angles are supplementary. Consecutive means one right after another, and supplementary means 180 degrees. All right, so those are the 5 facts that you are going to need to solve all the problems. Let's try a problem together. If you're looking at the smartboard that you should be able to open as a PDF, it's the first problem. I will draw it for us, and then we can solve it together. So if you printed it off, that makes life even easier, but you can just copy it down if you'd like and take notes along with me. So we're going to draw on the diagonals. So the diagonals go from here down to there. That is a diagonal of a parallelogram. There are 2 of them, from opposite vertex to opposite vertex. It tells us that this length right here is y. There. We have this length here is 30. We also have a few other things they tell us. They tell us this is 42 degrees. This is 55 degrees. And they go A, B, C, D. That's how they label the picture. So if you're copying down that picture, go ahead and pause and copy down. Otherwise, I will start solving. So there's 5 things they're going to ask us for. X, Y, the measure of angle ABD, the measure of angle ABC, and the measure of angle BCD. Those are the 5 things they will ask us for. So let's give it a shot here. See how many of those we can find. Starting with X, opposite sides will be equal in the parallelogram. So I have this side equal to this side. That's what those hash marks mean. And this side equal to this side. So I'm going to write 3x equals 33 because this side is equal to this side. That's why I put an equal sign between them. Divide both sides by 3. X is 11. All right, got X. Let's go after Y. Y is here, and 30 is here. Now, this fact about diagonals bisecting each other means they cut each other exactly into 2 equal pieces. So this length here will be the same as this one down here. So Y is exactly the same as 30. That's an easy one. You just had to write it down. And similarly, this part over here would be the same as that part over there. Okay, we've got our X and Y. Let's go find our angles. They're asking for angle ABD. Angle ABD. Remember, the B is my vertex. It's the middle letter. So ABD is that angle right there. This angle is going to match up and be alternate interior to 55 down here. From first trimester or second, Geometry A, your teacher probably talked about the Z shape. So this shape right here, the Z shape, creates congruent angles, alternate interior, if those lines are parallel. And the nice part about a parallelogram is that the lines have to be parallel. So this angle is the same as this angle down here. This is 55 degrees. Next up, angle ABC. Angle ABC happens to be the whole angle ABC. That's the whole angle. Because opposite angles are congruent, that means this whole angle will match up with this whole angle. This one and this one will be exactly the same amount. So to find this whole angle, I just add those two together. The angle addition postulate says to add up 42 and 55, 97, and that will be my angle here. 97 will match over there. The last question, angle BCD. BCD is here. BCD. I'm going to put 2 slashes on this angle because it doesn't match these two, but it does match this one. So we can put 2 slashes up there if we want. We have this fact right here. Consecutive angles are supplementary, and we'll use that. So this and this, these two are supplementary because they're consecutive. So if I'm walking around the parallelogram, I have this angle and then this one. They come right after one another. These two are supplementary too. So any two angles that are right next to each other in a line, they will be supplementary. So they add up to 180. So we're going to take this angle, 97, and we're going to add this angle to it down here. So 97 plus this angle is measure of angle BCD. I'm going to call that my variable, BCD. And total together, those equal 180. If you don't like the measure of angle BCD there, completely fine. Just put another letter, W or K, something like that, and define this angle to be that letter, and you can solve it the same way. So we'll subtract 97, and the measure of angle BCD is 83 degrees. That's how you would solve a problem like that when they ask for multiple parts. Let's do one more example. If you're looking at your smart board, the next example just says that there's a parallelogram ABCD, and it doesn't draw it for you. So you just draw a parallelogram. Try to make it look close to the real shape of a parallelogram, where these two look about the same length, and these look parallel. Right? It doesn't have to be perfect, but do your best. And it doesn't matter where you start. Just make sure you go A, B. Don't jump over here and do C. Go A, B, C, D. Work the perimeter of the parallelogram. Now they give us a couple lengths. So they say AB is 2x plus 5. BC is 3y minus 8. DC is 21, and AD is 7. From the past or the last problem, these two will be equal because they're opposite sides, and these two will be equal because they're opposite sides. So I can write an equation, 21 and 2x plus 5 will be equal. Subtracting 5, 2x equals 16. Divide by 2, x equals 8. Now, I know I go fast in my algebra, but as I mentioned, just feel free to pause these videos and catch up, listen to it a couple times, make sure it makes sense to you. Then we also have to find y. So we're going to go 7 equals 3y minus 8, adding 8 to both sides. 3y equals 15. Divide by 3. 3y equals 15. Divided by 3y is 5. Oh, and the problem, if you're reading it, it says just find x and y. It doesn't say plug it in and find any other lengths. So we are done. We found x equals 8, y equals 5. There are 4 practice problems for you. Download those, take a peek and try those, and then look at the solutions video for those if you need it, or at least scroll through it quickly to find the answer key, which would be at the very end. And then you got a Big Ideas online assignment. Have a great day. Mr. Manor signing off.